All right, let's talk about something you use every single day, probably without even realizing it. We're going to pull back the curtain on SQL, the invisible language that basically runs our digital world. It's how we talk to data, and by the end of this, you'll get exactly how that conversation works.
I mean, really think about that for a second. You tap open your banking app and bam! There's your balance. Your specific balance, plucked from a massive, swirling sea of millions, maybe billions of transactions. How on earth does it find your data instantly? It's definitely not magic.
Well, the secret is that it's all just a conversation. A very, very structured and super efficient conversation between your app and a database. And the language they're both speaking? That's SQL. It's built from the ground up to ask incredibly precise questions and get incredibly precise answers fast.
Okay, so let's make it official. What is this language really?
SQL stands for Structured Query Language. And honestly, that name tells you the whole story. It's structured, which means it has a strict grammar, rules you have to follow. It's a query language, which is just a fancy way of saying it's for asking questions. And it is the undisputed, hands-down industry standard for talking to relational databases, which you can just think of as giant, perfectly organized digital filing cabinets. Here's the best way to think about it. SQL has two main jobs. First, you have to actually build the filing cabinet. You've got to design it, label the drawers, we'll call that the blueprint. Then, once it's built and all your files are inside, you can start asking questions to find what you need, and that's the conversation. SQL does both of these things perfectly.
So let's start with that first job, actually creating the blueprint. In the SQL world, this is all handled by a part of the language called DDL.
DDL stands for Data Definition Language. Its entire mission in life is to define the structure. It doesn't care about the actual data, not one bit. It just builds the containers, the tables, where all that data is going to live. It's kind of like an architect designing the shelves for a massive library before a single book ever shows up.
And designing these tables is surprisingly simple. First, you give your table a name, say instructors. Then you decide what info you want to store in it. These are your columns. Things like an ID number, a name, a salary. And finally, you have to set the rules for each column, telling the database what kind of data it's allowed to hold.
And these rules, they're called data types. And you got to be specific. For example, is the ID always going to be exactly 5 characters long? Well, that's a char. Is the name going to be text, but you don't know how long? That's a varchar. Is the salary a number that needs decimal points? That's numeric. This detail is what keeps your data clean and stops you from, say, accidentally putting someone's name in the salary column.
And here's how that all comes together in one single command. See, it's pretty readable. We're telling it to create table instructor. That's step 1. Then we just list out our columns, ID, name, dep name, salary, and we give each one its specific data type, just like we talked about. And just like that, your blueprint is done, the shelf is built.
So, our digital library is ready to go. The shelves are built, they're organized, they're labeled. Now for the fun part, actually finding some information. This is where we move to the second part of SQL, the conversation itself. And for this, we use the DML.
DML, or Data Manipulation Language, this is what most people are thinking of when they say SQL. This is the action-packed part of the language. It's how you select data, insert new stuff, update things that are already there, or even delete them. This is how you really start talking to your data.
Now, the most common conversation starter by far is just asking for information. And the basic grammar for that question is almost always the same. It looks like this: select something from somewhere where some condition is met. Let's break that down real quick.
First up, select. This is simply you telling the database what you want to see. It's the what. You're saying, hey, I'm interested in the book's title, or in our case, maybe the instructor's name.
Next, from. This part tells the database where it should go look for that information. It's the where. It points to the exact table or the specific shelf that has the data you need.
And finally, where. Now this is the magic part. This is your filter. It takes your search from potentially millions of records down to just the ones you care about. It's how you say, don't just give me all the instructors, give me only the ones written by Isaac Asimov. Or, well, you get the idea. So let's look at a full sentence. Here we're saying, select the name column from our instructor table, but only where the value in the department name column is exactly comp sci. And boom, the database instantly gives you back a nice clean list of every single instructor in the computer science department. Simple, right?
Oh, and a quick pro tip for you.
If you ever just want to see everything inside a table, you don't have to type out every single column name. You can just use the asterisk or the star as a wildcard. Select asterisk is the universal shorthand for just show me the whole shebang.
So we have a blueprint, and we have a way to have a conversation. This simple but incredibly powerful structure is the reason SQL has been on top for so long.
And I do mean a long time. This all started way back in the 1970s as a project at IBM. It became an official standard in the 80s, and here's the cool part. It's never stopped evolving. It's not some dusty old language. It's constantly adapting, even adding features to handle modern data formats like JSON just a few years ago.
This quote from our source material really just nails it. When it comes to structured data, there really isn't another game in town. SQL is the de facto industry standard. In other words, it's the language everyone has agreed to speak. It is the lingua franca of data.
Which leaves us with this one big, fascinating thought. Right now, we're in the age of AI and these massive, messy, NoSQL databases that can handle any kind of unstructured junk you throw at them. So why is this 50-year-old language more important now than ever before? Because all that chaos, all that messy data, it's totally useless until you can find the structure inside it. AI models, business reports, dashboards, they all work by asking clear, structured questions to turn all that noise into real insight. And that is what SQL was born to do.